Hello everyone, my name is Abhishek Agrawal and I am currently pursuing my Masters in Construction Engineering and Management at SEPT University. As a part of our first semester studio, which is Construction Project Formulation Appraisal, we have carried out feasibility study on a project construction and demolition waste recycling plant at Ahmedabad. Now coming up to project brief, the goal of this project is to set up the C&D waste recycling plant in Ahmedabad. The client of the project is Ahmedabad Municipal Corporation and the project is funded by 25% by Swachh Bharat Mission and 75% by the Ahmedabad Municipal Corporation client itself. Ahmedabad generates nearly 4,000 tons of municipal solid waste per day, out of which 1,000 tons are construction and demolition waste. This highlights the urgent requirement of the dedicated recycling facility. The project is located in Ahmedabad, Gujarat and categorized as a brownfield intervention within the industrial sector. The objectives of the project is to include the waste reduction, value generation, sustainable urban development, encouraging legal disposal, and reducing the environmental impacts. The broader scope of the project includes the collection, transportation, processing of 1,000 TPD waste and the public engagement. So now coming up to the stakeholder management. Stakeholder management help us to identify all stakeholders, understand who is involved and classify them so that their roles can be managed effectively throughout the project. We have identified total of 54 stakeholders from which we have categorized them into 12 different categories. The categories are client, central government, state government, local government, contractor, consultant, waste generator, product buyer, vendors, private companies, plant management workforce, and other stakeholders. The bars are here highlight the local government, state government, and consultant form the large stakeholder categories, indicate that these groups have the strongest involvement in the project approval and the regulation operations. Power in, Now coming up to power interest matrix. The power interest matrix is used to see the how particular stakeholder power and how they interested in our project. So in the manage closely section, the group contains the client, Ministry of Environment, the Gujarat Pollution Control Board, and the project manager. These stakeholders have both high power and high interest and must be engaged continuously. The keep informed category includes the stakeholder categories like road and building department, the CND waste technology consultant, the operation staff, and the laboratory testing agencies. These stakeholders have a high interest but the lower power, so they need to regularly updates. The keep satisfied group includes the political leaders, the municipal finance board, and the national green tribunal, which have the higher power but the lower interest. They, so they have to manage day by day. In, so they have lower day by day involvement. In the monitor categories, stakeholders like the individual households, the NGOs, and the equipment suppliers who have lower power and the low interest but still play a minor supportive role. Thus, the inference highlights that the authorities with the regulatory function fall under the manage closely with low involvement stakeholders require only periodic checks. Now coming to power influence matrix, authorities such as AMC, MOU, HUA, MOEFCC, and the State Pollution Control Board fall under the manage closely because of their strong influence and decision-making roles. High power but the low influence groups like a finance board fall under the keep satisfied. Logistic agencies, contractors, and technical consultants fall under the keep informed. Low power groups remain under the monitor section. In the influence impact matrix, the managed closely categories like AMC, consultants, and the pollution authorities because their approvals and decision directly shape the project progress. High impact but the lower influence groups such as the estate department fall under the keep satisfied. operational agencies, and the development fall under the keep info group. Low impact and low influence group like NGOs and households remains in the monitor section. The stakeholder management tells us how the regulatory bodies and the major consultant have a central role in the shaping the project decision, and they must be prioritized for coordination. So now coming up to location analysis. Location analysis help us to identify the most suitable city and the land parcel for the establishing the CND waste recycling plant based on strictly not on the scoring and feasibility. We have conducted the detailed assessment based on the macro and micro parameters to ensure the chosen site meets the environmental, regulatory and the operational criteria. For the macro parameter, we have considered population growth, CND waste generation, waste recycling facility, registration projects under RERA. So here are the registered projects under RERA for each cities. For Ahmedabad, it is 5017. For the Surat, it is 2304. For Vadodara, it is 2738. The first graph shows here the population growth of each city in year 2011, 2021, and 2031. The second graph shows here the amount of waste generated, treated, and the amount of waste is landfill in the Gujarat in tons per day. Now coming up to the macro analysis. At the macro level, we compare the three major cities, Ahmedabad, Surat, and Vadodara, using the weighted scoring system. The aim was to identify the city base suited for establishing the CND waste recycling plant. Ahmedabad scored the highest marks. The inference state that the Ahmedabad stand out with the industrial activity, high waste generation, stronger waste management network, and the greater number of registration projects. Now coming up to the micro analysis. After selecting the Ahmedabad, the next step was to evaluate the three potential land parcels. We have selected Gyaspur, Patpa, and Sanan using micro level scoring. The parameters include the land use compliance, buffer distance, the distance from collection point of CND waste plant, connectivity in kilometers from highways, utilities, and the expansion potential of the facility. The inference explained that the Gasur has a existing waste management ecosystem, better connectivity to AMC facilities, and minimal environment conflicts. So Gasur is the best location for our project. Now coming up to the now coming up to choosing by advantage. The first design problem is to type of waste processing system for the waste recycling facility. Choosing the right waste recycling process system is crucial for environment construction and demolition waste recycling and the circular economy outcomes. It must handle the mixed material like concrete, bricks, metals, woods, plastic, so they can separately treated and turn into the reusable products, affecting the recovery rates, product quality, operating cost, resources conservation, and environmental performance in the long term. The alternatives we have choose for the problem one is the dry processing system and the wet processing system. Seven parameters were evaluated like recovery rate, power consumption, water requirement, plant footprint, recycled product quality, environment compliance, and the material recovery. Dry processing system scored 270 IOFA, while the wet processing system is scored 460 IOFA. The inference showed that the wet processing system is preferred because it offers a higher recovery efficiency, better product quality, and a stronger environment compliance, even though it is use more water and has the higher cost. Now coming up to the design problem two, selection of stormwater drainage system. A stormwater drainage system is in the CND waste recycling plant handles the runoff from exposed areas to stop flooding, erosion, and contamination. It ensures stormwater is quickly collected and safely discharged. A proper design with enough capacity and the treatment supports the reliable plant operation and environmental compliance. The system protects the infrastructure, maintains safety, and reduces the environment impacts from runoff. For the problem 2, we have considered two alternatives. First one is the RCC MP3 pipe system. Second one is the RCC line channel system. The parameters we have considered for comparison is the drainage capacity, durability, service life, safety, installation time, and the accessibility. The pipe system scores 360 IOFA, while the channel system score is 390 IOFA. Even though the channel system is cost more, it offers a better accessibility for maintenance, easier inspection, and the flexibility for future growth. It also improves the surface flow management. Now, coming up to conclusion, in the stakeholder management for the C&D waste recycling plant, emphasizes the importance of the engaging key authorities like the Ahmedabad Municipal Corporation, Ministry of Environment, Forest, Climate Change, State Pollution Control Board, and the consultant to secure the approvals and ensure compliance. For the location analysis, compared Gaspur, Vatva, and Sanand based on the connectivity, regulatory fit, and the distance from the collection points. It identifies the Gyarpur as the best choice because of the closeness of two existing waste infrastructure and AMC operational network. It lowered the transportation costs and better fit with current system made it for the most of efficient and sustainable operation. For the choosing by advantage, methods allowed for the objective evaluation and the alternative by focusing on the advantage rather than the cost. This made the wet processing system the preferred option for the better recovery and the compliance. The channel drainage system also scored the higher because of its long-term accessibility and the operational flexibility. Overall, CBA provides a clear, measurable basis for the decision that supported project sustainability and the performance goals.